Hi, my name is Courtney Wilson, and I am doing Lab 16, Ocean Acidification. Bless you, bless you. And sorry, my dog. And I am doing Ocean Acidification for my Discovering Science class. So already I have boiled red cabbage or purple cabbage, and then I let it sit for 15 minutes, and it's supposed to be purple. Honestly, mine kind of looks more blue. It's like a blue purple. That's extra in case this isn't enough. So right now I'm going to fill up my 4 tests with half a cup of water. For my 4 tests, I do have lemon or lime juice. I have lemon juice. And then I have baking soda up here. And then I also have a white vinegar. So right now I'm about to do the half cup of water in each of them. I'm just doing regular room temp. I am just doing regular room temp. These cups are really cool because these are half a cup. Half of it is half a cup. Also, I did a clear glass, just because I'm trying to use what I have. All right, so now that I have half a cup of water in each of my tests, my next step is then to add 1 teaspoon of our pH indicator, which is what we made when we boiled that cabbage. So I'm going to just go through, and it is 1 teaspoon. So makes it kind of like a light. Mine's a blue. I know that the thing says a purple, so I'm not quite sure what I did differently, or if my cabbage is just a bit different. It's a red cabbage from Walmart. Okay, pour this one. All right. So I am going to use a spoon. Sorry, kind of a clean freak. I am going to use a spoon and just make sure that those are all mixed. So we are starting with accurate data. All right, so these are my 4 cups. My first one, it says just to do like a spoonful of each. So I am going to do baking soda first, just because it is a powder and it won't ruin my spoon. So I can use the same spoon for the others. All right, so I have a spoonful of all right, so I'm doing baking soda in this one. Let's watch what it does. Interesting. All right, so that was baking soda. My next one I'm going to do is vinegar. Oh, that is smelly. Vinegar. All right, so I did just a spoonful of vinegar. Oh, that's cool. So that instantly changed to like a light pink. I could put this behind. It made it a light pink. It's really cool, actually. So a light pink, a lighter blue. My next one I'm gonna do is lemon juice or lime juice. My apologies. And each time I am rinsing off my spoon, so it's not getting into the next subject, the next test. So this is going to be lime juice. Oh, weird. So it is looking like this is like a clear pink, and this is making a cloudier pink. So, a bit odd. And then my next one, I'm going to do some lemon juice. And again, rinsing off my spoon. And I'm going to actually squeeze this over here. All right. So I have lemon juice into this touch subject. So that made it a pink as well. A little bit darker of a pink. A little bit darker of a pink. Huh. Alright, sorry. Video might be a bit long. Alright, so the order in which I did these again is vinegar or baking soda, vinegar, lime juice, and then lemon juice. So I'm going to put that over here so I don't forget. So this was our baking soda, and it did make it into a light blue. And then this was our vinegar. It's like a light pink. Let me grab a piece of paper here. So it is like a light, I would say it's like a light pink. This one was our lime juice. And I would say it's also a light pink, but cloudy. And then this last one was our lemon juice. And I would say it's a darker pink than the other two. So, just for quality. So, this was vinegar, lime juice, lemon juice. So about the same, but it goes super light, cloudy, and a dark, richer one. And I don't know if that also has something to do, because my picture looks a bit different than Dr. Springer's. And it might have been because her water started off more purple than mine did. Because again, mine started off this color. So, it might have something to do with that. So the next part of our experiment is, is to set 2 cups. So set 2 cups. I am going to do taller glasses so I know that they're separate than my other ones. And I'm going to move these out of the way. So she wants us to pour 1 teaspoon of the pH indicator in 1 cup of water. So I'm gonna do a teaspoon, 1 teaspoon, and 1 teaspoon, and then a cup. And again, I'm using all room temperature water. So we have a very, very light blue. And I would say that's due to how much water we now have in it. So we have a very light blue. So it is very, very light. For reference again, it is very light. And I think they look the same. This one's just not quite in my light in my apartment, but they're the same color. If you look at them, we are the same color. And then this one is going to be let alone for our control. So my left is my controlled one, and my right, we are going to use a straw to blow bubbles. And when we blow these bubbles for 1 to 5 minutes, we're going to start looking for a distinct color change. And the reason for this is that when we breathe, we have carbon dioxide, and carbon dioxide changes the acidification in oceans and waters and pH. So yeah, I'm going to start right now. Also, sorry, I don't know how to pause my video to be able to restart it. So we're gonna enjoy this together. Okay, so it's been a little over a minute, and you can already see the change. This one's like a light purple. Not sure if the video will show it as clearly. It's like a light purple. Probably what my water should have started off looking like. And then this one, our controlled, which we haven't done anything to. It's just the water and our pH indicator. It's still that light blue. So we can see that when we're putting carbon dioxide into pH, it starts to acidify it, and it makes it, the carbon dioxide reacts with that water and makes a carbonic acid, and this is what acidifies the water and turns that pH indicator a more pink, light purple color. So very, very cool. Got to see what was happening with our oceans in a simple at-home manner. All right, so now that I've done all the tests, there were a couple of things to indicate in our video, and I did write them down beforehand just so I could keep it straight of what I was thinking. After watching the videos and after looking at the lab, well, I hadn't conducted it myself yet when I came up with these answers. It was after looking at your lab and just seeing what had happened. So question number 1 is, in my own words, explain the process of ocean acidification and include the cause and effects. So a simple way that I put it is it happens when it occurs when CO2 is absorbed into the water, i.e. the ocean, seawater, at a very high rate. It reacts with It reacts with H2O to form a carbonic acid. That's what we just did here, was when we blowed bubbles into it, it formed that carbonic acid. This then breaks down into a hydrogen ion and a bicarbonate. Having these ions is what decreases the pH, which acidifies the ocean. So the cause and effect of this, the cause for ocean acidification is because us as humans, we are so developed and we are creating so much CO2 into the world. We are putting it into the oceans when we're driving our vehicles, when we're creating new technology, with all the machinery we have in today's world. And that is affecting more CO2 to go into the ocean, and it's reacting with the H2O to create that carbonic acid. And when we are creating this, the pH in this decreases significantly. So us putting out so much CO2 is decreasing the pH, which rises the acidification of the ocean. So pH and acid, they're like this. Same like when you have a hot tub or a pool, you want to balance out the pH in this acid because you don't want something that is too acidic, but you also don't want something that's has too much pH. So that's the cause and the effect. That's the cause of ocean acidification. And the effects, I go more in depthly on the effects of ocean acidification in my second the second part of this question. But basically, what happens when we decrease the pH and we increase the acidification in the ocean is sea animals start to die. So now going into part 2, where I'll explain more. So it's asking if I'm concerned about ocean acidification and explain why are we not, using specific examples. My examples are my effects. So for this question, the way it's asked, no, personally, I'm not concerned. Like, I don't think about this every day. I don't think about ocean acidification much. However, is it a cause for concern based off of what we watch? Yes. So am I personally concerned? No. But should we all be? Yes. And the reason being is that based off of the video, the second one's where I got a lot of the information on why we should care. It's because the ocean covers 2/3 of our planet, and it also provides half of our oxygen, which is a lot. And I also heard that a lot of that comes from whale poop, which eats up CO2. So that thought was intriguing. So with this, the ocean absorbs 2/3 of the CO2 that is in our world. But because of humans, we have pumped more CO2 into the atmosphere, which means that more CO2 the ocean is trying to absorb. And this is then causing that pH to go down because that CO2 reacts with H2O to form a carbonic acid. This then breaks down into a hydrogen ion and bicarbonate, and these ions decrease that pH. So it is causing, all of this is causing the pH to go down in the ocean. This makes it hard for some corals, planktons, and like shellfish. It's making it really, really hard for them to form their shell/skeletons. This is killing our reefs, it's killing our fish, our algae, it's killing our ocean. Now, the second video did say that some animals, some sea life is actually excelling and they're doing really, really well. And I would be interested in to see if that's because of the low pH. However, she did say that a lot of our sea life is being killed off by the lowering of the pH and the increase of the ocean acidification. So this means that mass extinction could happen. Which is actually pretty scary because a lot of our 20% of our food comes from the ocean. The ocean again eats up 2/3 of our carbon. It produces half of our oxygen. So it should be, based off of this experiments, based off the videos, based off of what I'm learning about ocean acidification, it is a cause for concern. And it is something that I think the world needs to realize a little bit more about our CO2 output, because while we may not see it very much here in Wyoming, it is super bad. I tried to run down in Colorado Springs this past weekend, and there's so much exhaust that it was honestly really, really hard to run 6-8 miles. So I do think it needs to be a cause for concern because our oceans, once they die, we're dying. So it's definitely very, very important. So one last time, ocean acidification happens when CO2 is absorbed into the water, the ocean, at a very high rate. It reacts with H2O to form a carbonic acid. From this carbonic acid, a hydrogen ion and a bicarbonate is created, and those ions are what's decreasing the pH in the ocean, which increases a rise in ocean acidification. This is affecting our sea life, which then in turn affects everything else. The ocean gives us our oxygen, it eats up our CO2, it provides food, it provides half of our oxygen, and it also without the ocean, our world would not exist. So it is a very important, ocean acidification is a cause for concern, and I hope that I did this project right. Again, controlled substance, light blue, with bubbles blown in, which is making the pH go down and the acidification go up. this, and then our test subjects. Still cloudy, still light, a darker pink, and a very pretty light blue. And that closes out this. Again, Courtney Wilson for Discovering Science.